Hi there, viewers, and welcome to my latest video looking at how to use manipulatives and representations to support maths teaching in secondary schools. Today, we're going to look at solving linear equations where the unknown appears on both sides, and we're going to look at a couple of different models for this and how the manipulatives can support making sense of this model. The first model you can see on the screen already is we're going to use what's called an object view of the model, or a discrete view of the equation, where we have the tiles on this side, the algebra tiles, representing the 5x minus 2. And on this side, we have the tiles representing 3x plus 8. And you can think about this kind of like a pan balance or something similar to that. The idea is the value of the tiles on this side has to be equal to the value of the tiles on that side. And how can we use the tiles to make clear what the value of x is? And basically, this is going to mirror the process that many people would follow in the abstract. We're just using the tiles to show what's happening when we do this in the abstract. So what we'll notice first is that there's some x's on this side and there's some x's on this side, and those sets of x's, these three x's and the three x's over here, must be equal to each other. And so I can remove both of those sets of three x's without changing the equality, i.e., if these three x's are equal to these three x's, then what is left on each side must also be equal to each other. And so I'm simply going to remove those three x's, and then I'm going to remove the three x's on the other side of the balance. There we go. And I can record that, doing that in the abstract, and this is the sort of recording that we'll do with students all the time, that we've removed three x's from this side, and we're going to remove three x's from this side, and we can see that what we've got left, it's not great writing there, but there we go. What we've got left on the left-hand side is a 2x and negative 2. And what we've got left on the right-hand side is just 8. And of course, now we're in that simple linear equation setup where we've only got x's on one side of the equal sign. And so now we can focus on the numbers involved on each side of the equal sign. And we can see here I've got negative 2 on this side, I've got 8 on this side. And so again, what I can do here is I can clear that negative 2 from the left-hand side by adding 2. But of course, if I've added 2 to the left-hand side, I also have to add 2 to the right-hand side. And so again, I can map what I've done there in the abstract, add 2 to this side, add 2 to this side. And what we've got left now on the left-hand side is just 2x. And what we've got left on the right-hand side is now 10. And then finally, of course, I've got these two x's, and what that means is I can split those two x's into two separate parts. And that means I've also got to split the 1's into two equal parts. And we can see that each of those x's lines up with 5 1's. So I've split those two x's into two equal parts, and I've also split the 10 into two equal parts, and so each of those x's has an equivalent value of 5, so x equals 5. Now that, like say, is using a discrete view, an object-based view, where the objects on the left and the objects on the right have to have equal value. And if, as I mentioned before, particularly if you've seen my simple linear equations video, the slight issue with that one, the equality in that has to be sort of imposed. There's nothing to say that what's on the left-hand side and what's on the right-hand side actually are equal at any point, except me telling you that they are equal at any point. A possible alternative for this that sort of gets rid of this is if we look at this using a bar model, and we can see here that we've got the same equation, although you might not see it immediately as the same equation. But what we've got here is we've got 5x's on the top line, and we've got 3x's plus 8 on the bottom line. And although I could have had a single bar with the 8 in, it makes it slightly easier to sort of manipulate this virtually if I have 8 ones rather than a single 8. And what we can see here with the brace is that the difference between these two are 2. And if you're familiar with bar modeling, you may well have seen the use of a brace before to show the difference between two numbers. And that's how we're interpreting this subtraction here. We're interpreting it as the difference between 5x and 3x plus 8 is 2. Okay, so the difference, so 5x subtract 2 results in 3x plus 8. And again, we can do much the same thing as we did before. The slight benefit this time is that the equality of the length is what tells us they're equal. So there is an equality implied in this diagram, and we can see here that if I were to simply cut off the diagram at this point, this part would be 2 more than this part, if you like. And that's exactly what happens here. I remove that part of the diagram, or I can just cover it up or ignore it. And of course, what I've done is remove 3x's from the top line and the bottom line, and I'm left with that equation that 2x and 8 have a difference of 2. So 2x minus 2 is 8. And then I can say, right, well, if I then replace this brace with 2 more of these 1s, so I add 2 into the picture, I now have that equality that 2x equals 10. And then, of course, again, I can split that into 2 equal but separate bar models. And that shows me that each x is equal to 5. You don't actually have to do the separation there, but I'm doing it here so you can see clearly that I've got a single x being equivalent to 5 ones. So that one has the advantage that the equality is imposed within the model. The fact that they're both equal length, or that the x's and the ones with the brace made that equal length, shows the equality. Bar modeling, though, with equations of this type does tend to struggle. You do tend to struggle to form the bar model a little bit more when the value of x is negative. So you have to think about that. You have to think about your values of x if you're going to use it in this way. So that's my short video on solving linear equations with unknowns on both sides. As always, I'd like to give a big shout out to Johnny Hall, the creator of mathsbot.com, whose website I've been using for these excellent virtual manipulatives in order to create these videos. And I look forward to speaking to you again. Thank you very much for listening.